Good afternoon, everyone. How are you? Yeah, you ready? You ready to have some fun? This is one of the great, I love doing this session every year at Automate. You get to see some of the earliest stage, most promising, cool ideas from our 10 startup finalists here in this competition. It's going to be a really great session. Thank you for being with us. And yeah, let's kick things off for us. So, my pleasure to welcome you. I'm Alex Shikani. I'm going to be kind of your MC, your host for this session. It's a pleasure to be with you today. You know, this competition is brought to you this year by two incredible companies that need really no introduction, NVIDIA and Microsoft. And two of our judges are here with us from NVIDIA and Microsoft, actually. And to say a few words to address you, I'd like to actually welcome Christy DeCoeur and Britton Winterrose to the stage. So please help me welcome them.
Can you hear me? Well, welcome to the Startup Challenge. I'm Christy DeCoeur. As he mentioned, I work for NVIDIA, and I focus on building our ecosystem of strategic partners in robotics. I am so excited to be here today because we went through a huge list of amazing partners. So those that you're about to hear from are terrific, just like all of them, but these made it to the top. So I'm sure you'll enjoy the opportunity to hear about their technologies and how they fare.
Hi, everybody. I'm Britton Winterrose from Microsoft for Startups. I want to say, first off, congratulations to all the finalists. I was a founder before in the past, and I remember the excitement, nervousness, highs and lows of going through and pitching, singing for my supper, so to speak. And I just want to say we're very proud of you. We'd love for you to come and use our products. So you can always visit Founders Hub on Microsoft for Startups. Just type in Founders Hub. That's the easiest way to get connected with our team, our program, and hopefully some credits to help you with the compute side of building what you are building and doing what you're going to set out to do. So congratulations again, and may the best team win. So.
All right. Thank you, Christy and Britton. We also have three more judges to round out our 5-person judges panel that's going to be making the tough decisions today. And I would like to ask them to maybe stand in place and introduce who they are and where they're from. So,
Sean Simpson from Newlab. Newlab is a location-based venture platform. Locations here in Detroit, New York. Recently announced Saudi Arabia, and yesterday announced our newest location in New Orleans. Glad to be here, and looking forward to seeing the competition.
Hi, I'm Lisa Chai, General Partner at Outsell Ventures. We are an early-stage venture fund in New York, investing in the field of robotics and artificial intelligence across multiple industries, including manufacturing, logistics, transportation, and healthcare.
Hi, good afternoon. I'm Oliver from FF Venture Capital. I'm a partner there, focused on deep tech. We invest in AI, automation technologies like Plus One Robotics, one of our portfolio companies, or Cambrian Robotics, as well as agricultural companies like Burrow Robotics and Managed Drone Delivery. And I look forward to hearing the startups. And just published a book called A Startup Field Guide on the Age of Robots and AI. So if you like my comments, you can buy the book on Amazon. So thanks so much.
All right, let's hear it for our judges. They have a tough job. Okay, and now, without further ado, a procedural note. We're going to proceed alphabetically with our finalists. They're going to give pitches for about 5 minutes of content. Then there's going to be 5 minutes of Q&A from our judges right there. And then we're going to change over, and we're going to move at that pace, 10 minutes per company max. And then we will dismiss the judges. They will decide, and we will have an award presentation. So without further ado, our first contestant, everyone, please help me welcome to the stage 3 Laws.
All right. So, hello, everyone. My name is Andrew Singletary, and I'll be presenting my company, 3 Laws Robotics. We do what we call dynamic safety guardrails for all types of autonomous systems. So mobile robots, manipulators, and a lot of other things that you're going to see in this presentation. So I want to open with what dynamic safety is. Dynamic safety is the idea that safety doesn't have to just be slowing down and stopping. It can be real-time decision-making on what you need to do in order to stay safe at any moment. Not only does this have obvious benefits in terms of being more productive by staying in motion, but it's often critical. There are a lot of times where you just have too much inertia and you're just not able to slow down and make a stop properly. And I think that's shown best in kind of the autonomous vehicle space. You can see in this, I'll play this video twice if I can, but you can see someone fell off of a scooter, and the Waymo vehicle here had no time to stop in front of that individual. The only way it was able to keep things safe and prevent a casualty was by actually moving out of the way and making that real-time decision. So one more time, just because I know it was fast, but you can see, the scooters on the right, and then they just immediately fall into the road, and the Waymo was able to make that real-time decision to keep them safe. So it's incredibly important to be able to think about safety in a dynamic setting. And that can really be applied to robotics, and particularly in terms of improving the productivity of these systems. So a lot of robots, their safety case requires them to be able to come to a complete stop. But if you're able to relax that requirement and take a dynamic safety approach, then you're able to increase throughput and do things like move around people as they appear in real time. And so that's really what 3Laws provides. We provide a dynamic safety layer that's taking in more sensor data than just your typical safety-rated sensors, but 3D cameras and LiDARs, and really being able to understand the environment, understand the dynamics of the system, and make intelligent decisions in real time that are verifiable and provable. And so how we work more concretely is we are a layer that sits right above the embedded control system of a robot. So embedded control systems are typically very safe, high safety integrity level systems that are tracking commands that come from the brain of the robot or the autonomy layer. And so we fit right above that, kind of filtering the motion planning signals, if you will, before they come down to the lowest level of control. And interfacing there has a lot of advantages in terms of the universality of the product, because a huge number of systems are architected in this way. We don't have to be inside of the motion planner or the controller. We can be a separate node like this. So, the primary use case in robotics is just keeping these systems moving and doing real-time replanning when there's incidents. So this is a fast food frying robot. They had issues with collisions because they have to plan so quickly in a kitchen environment. And so we were able to simplify their motion planning problem by providing this dynamic safety layer, which was able to do this real-time trajectory rerouting and velocity signal modification to keep it safe. And if you go downstairs to our booth, you'll see a multi-robot AMR environment. In these environments with a lot of robots, you typically get gridlocks and e-stops, and we can avoid those with our technology, as you can see if you go to our booth downstairs. The technology that has enabled us to do this is fundamental science out of Caltech. So this is where I did my PhD alongside my co-founders, studying this math we invented called control barrier functions. So this is now a very well accepted and proven math construct. It's got tens of thousands of citations. There's more than 1,000 papers written from top universities on control barrier functions in the title. And we worked with some really great industry partners across automotive, aerospace, and robotics to get this tech to the point where it is now. And so these are all the types of systems we've deployed on. And I'm thrilled to say that we've actually flight tested this software with the US Air Force on an F-16 platform. So they are testing these AI agents to control the jets, and we were able to come in and provide a deterministic safety layer that sits at the output of the AI and at the input of the flight control system to keep things safe. In the context of robotics, industrial robots as they are now are quite safe. So the KPIs we really focus on by bringing in our safety layer is, increasing the performance of these systems. So how do we improve productivity, improve throughput without reducing safety and maintaining the same level of safety and regulations? Doing things like more optimal paths because you don't need inflation radiuses, better average speed along mission, and less time between interventions or e-stops. So that's what we do. Please come see our booth downstairs at 8922. We also have a booth over in the startup area where I'd be happy to talk to you, but there's lots of different use cases in robotics that are highly applicable to this technology, and I'd love to tell you more about ways we can speed up your robots while keeping them safe. So, thank you. I can come down.
Okay, got it. Could you just talk about your business model in terms of pricing?
Yeah, absolutely. So we work on a per robot licensing model that's recurring. So we're not only providing kind of the collision avoidance and safety functionality, but also a means for people to track their productivity and the improvements in their productivity. So it's a per robot licensing model that depends on the type of system that we're on and the number of constraints that need to be enforced. For example, legged platforms need not just collision avoidance, but things like stability constraints. And so that's a bigger lift than something like a more traditional AMR.
You have lots of different use cases in the deck. Where are you starting out? Who are your customers? And where do you see it going?
Yeah, so our primary use case that we're starting out with are warehouse robots. We took a long look at like where's the biggest need for this product, and it was really in factories that are deploying AMRs and suffering from productivity issues due to safety systems that weren't designed and implemented in a way that allowed for that productivity. The other vertical we're actively exploring is aerospace. We've got a number of projects going on with the U.S. Air Force, as well as some other primes, in deploying this as the Air Force is looking to bring more and more advanced autonomy. We're deploying on different types of fixed-wing aircraft.
How do you handle the customization maybe needed for like different robot types, different applications? Like, are there kind of economies of scale where there's similar problems to solve? Because it seems like there's a ton of different types of robots, ton of different applications. There'd be a lot of custom one-off integration required.
Yeah, so that's actually the primary advantage of the layer that we interface at. So it would be hugely difficult if we were an embedded control layer, because then there's all these different motor controllers. On the jet, we would have had to learn how to do surface control of an aircraft, which is well beyond the scope of the project that we had. And so by sitting at that layer and being able to leverage the existing tracking controllers on the system, we can fit in very easily. And almost all autonomous systems, whether it's in aerospace or automotive or robotics, they all have this kind of modular architecture where you're doing perception in one node and planning in another node and control in another layer. And so because we sit outside of those, we just need the input signals that are coming from these different nodes, and we can make our decisions.
How do you size the market potential for this technology?
Yeah, it's really difficult to do like holistically, because the vision of 3 laws is in the name. It's Isaac Asimov's 3 laws that protect people from robots. And so the vision of 3 laws is to be on anything that moves. And so obviously sizing that market is incredibly difficult. So we like to look at specific use cases. So how much are people paying for safety right now in the specific domains? What can this unlock? Like an example would be like the flight testing market, right? You can see that for a new aircraft development, $200 to $300 million is spent in flight testing this aircraft. And what we proved with the Air Force is that we can dramatically decrease the amount of times you need to flight test by actually staying on mission with our safety system and letting them operate at the edge of the envelope. And so we kind of look at each market individually in terms of what can we offer, what are people paying right now, and then what are the values we're giving them beyond just the safety layer in terms of the productivity. Thank you.
Andrew, thank you very much. Appreciate it. Nice job. Nice job. So for our next competitor, I'd like to welcome to the stage AirTrack Robotics.
What's going on, everyone? My name is Chris Lee, co-founder and the CEO of AirTrack Robotics. How are you guys enjoying the show so far? We're seeing so many cool robots out there, right? We've got manufacturing robots, warehouse robots, and all these different kinds. But have you seen any robot that is for the aviation industry? At AirTrack Robotics, we're making autonomous robot to transform aircraft ground handling process. Think of the last time you were flying. Have you noticed someone on the ground walking with the wing as your plane enters or leaves the gate? Those folks are called wing walkers, and their job is to be an extra set of eyes to ensure safe ground movement of your aircraft, especially around the hangar and the ramp area movements. Their job is critical to safeguard the aircraft, but it is quite simple. All they need to do is walk with the wing and communicate with the lead operator who's guiding the aircraft for any potential hazards in the aircraft pathway. The problem is, because of this simple task, aircraft operators have to schedule at least 2 wing walkers, sometimes 3, including the one at the tail, for every arrival and departure. And this consumes nearly $1 billion just in labor, just in the US. And there's a risk of a human error as well. In the aviation industry, the cost of human error is very, very expensive. The total damage cost due to the human error is estimated at nearly $10 billion each year. So our solution is to automate this wing walking process using autonomous robots. By freeing up human staff from this simple and repetitive task, our solution reduces the operational burden for aircraft operators and mitigates the risk of aircraft damage from human error and an oversight. This is our the solution will work. So in this particular example, the lead operator is going to be the driver of that tractor pushing the aircraft back from this parking position. Then the lead operator will have the tablet where they can click a button and summon the robots. Then our robot autonomously finds their position next to each wingtip, move with the aircraft while scanning the aircraft pathway. Then this scanning information will be shared through the tablet so that lead operator can guide the aircraft safely around the hangar and the ramp area. Total global market for this wing walking automation is estimated at $18 billion. In the US market alone is the $5.6 billion. Our beachhead is the $300 million US business aviation market where we can commercialize this technology without going through regulatory hurdles. We offer the customers the robot as a service for our customers with the 12-month ROI. This number that you see here is based on the letter of intent that we secured from our initial customers, and the operation is a rather small operation, and for other bigger customers, the number will scale based on the size of their operation. In terms of the competition, we're the only robotics-based solutions in the market. Unlike our competitors relying on hangar-mounted, fixed-based the sensor packages, our robotic-based mobile platform effectively reduces the stepping requirements, addressing the needs of both indoor and an outdoor wing walking. So we have a significant advantage over the competition in the market. Our team met at our previous venture-backed startup, where we worked together and developed autonomous airport baggage tractors that was deployed across the US airports. So we bring strong domain expertise in this space, and also we have the advisory board of industry experts from Frontier Airlines and the Delta Airlines, which makes us the right team to tackle this problem. For the past few weeks since we started this project, we picked up a lot of exciting the market traction, especially from the US business aviation sector. We're partnering up with some of our customers for product development using their hangar facilities, which we'll make announcements soon. And also, we secured a letter of interest from Frontier Airlines, which demonstrates our upside potential into the commercial aviation sector. With this exciting market signal, our goal is to complete the product development and launch in 26 and grow from there. And to make all this happen, next 24 months is really critical for us. So we're raising our pre-seed round at the moment. I'm happy to talk more about this afterwards if you're interested. So at AirTrack Robotics, we believe that the automation is the future, in fact, the inevitable future of the aviation industry, and that we're trying to position ourselves as the front runner and the industry leader in the market. So if our mission resonates with you, please feel free to reach out, and thank you for listening to our story. Thank you.
I'm sorry if I missed this when you were talking about Reynolds. So that's just a commitment. Have you started
the traction-wise?
Yeah.
Yeah. So today we have a letter of intent from the one customer, and the rest of them are still on the prospect level. But some of them offer the coming to our facility. We can develop this together, and so we're kind of developing our relationship with the customer today.
Got it. How long do you expect the implementation time to be once Reynolds go?
Are you talking about the implementation at the hangar facility once it's all developed?
Yes.
The implementation-wise, all we need is we just need to go in and map the other hangar facility and the ramp area outside the hangar, which is normally not super huge compared to the the entire airport environment. So I don't think it's going to take more than 2 weeks or so.
No one else? Can you talk to me a little bit about the cost today, of the guy with the flag versus your costs? and the efficacy of your solution versus the guy with the, with the flag? What are you're up against humans, so how are humans doing? What do they cost? What's the real problem there?
I can't really hear well, but I think they're asking about the cost of the current way of manual wing walking, right? Yeah. So for example, one of our customers, like they're having about 20 daily flights coming in and out. So they need each wing walking session takes 10 minutes for coming in and coming out, like 10 minutes and 10 minutes. And so the $20 per hour per person, and that they need 2 people, and 10 minutes, like they use their 2 people's 10 minutes at each time they move the aircraft. And sometimes for the business aviation side, to get one aircraft out to get them fly out for their clients, they need to move 15 aircraft. So 15 aircraft out, get the last aircraft, let it fly, and then bring the rest of the 15 aircraft back into the parking position. This takes easily 2 to 3 hours. So that's when the other things get super expensive from the labor perspective. And in terms of so we call it hangar rash, and it is an industry term that describes the human mistake and the aircraft wing running into the hangar walls and things. The hangar rash, the average the damage from the hangar rash is about $124,000 in the business aviation. So the one instance can to bring up the whole cost to the certain level. So that's why there are customers one of the customer experienced a 6 hangar rash for past 6 months. And the other customers experienced a hangar rash that exceeds over $1 million for the cost that they have to pay for. So that's what drives this type of the automation solutions from our customers' perspective.
And what is your cost savings?
Oh, in terms of our cost savings, so we target 2 to 4. In terms of the full-time employee perspective, we're looking for 2 to 4 an FT cost reduction. So that's our target within the 12 months, and that's what is generally the aviation industry players are looking for new solutions.
I'm probably naive, but is there any FAA regulation around
That's a
humans
very good question.
where humans have to be in the loop with these?
So that's why we are starting from the business aviation side. The wing walking in the business aviation is not regulatory requirement. It's some individual business best practice operating procedure to safeguard their own aircraft. So adopting our solution is going to be their individual business decision. Commercial airline is a little different because they're running on the Part 139, commercial airports, that is right under the FAA regulation. So they have to do something. They have to report to the FAA for their change of the operating procedures and stuff. So our strategy is the commercializing the business aviation, and I use this as a reference to go talk to the airlines, FAA, and all those folks to commercialize it in the next sector. All right. Thank you. Oh, thank you.
To Chris. All right, moving to our third contestant now, I'd like to bring to the stage Bucket Robotics.
Hi, everyone. My name is Matt Pahalski, and I am founder of Bucket Robotics, where we provide robotic vision for manufacturing. We're backed by Y Combinator, and I'm here today to talk about a deeply unsexy problem that's definitely plaguing everyone in this room that's involved in manufacturing, which is slide control, which is surface inspection and quality control, specifically focusing on the problems involved with being able to dial in defects and understand what is going on in your production line. At Bucket Robotics, what we do is solve the problem that plagues so many manufacturers in the injection molding, casting, and machining space, which is answering the question of what exactly is a defect and when do I know when that error occurs. Some of the big problems that we see is the subjectivity involved with defining defects and finding data of where problems arise. So this is incredibly common, and then even more important, very recently, as we see in manufacturing, there are changes in how people are producing and moving to new machine shops as the global market moves around. So moving to a new production facility or changing a new method means that you have a whole new data set and new issues. How we solve this is we start from the basic atomic unit of every component, which is CAD, and we build a synthetic data set around that to help dial in exactly what a defect is. It's a very easy process where we start with, say, a step file, and then answer some basic questions around what types of defects do you care about? Is this a Class A surface in an automotive environment where I care a whole bunch about one side and I just want to see my SKU on the other side, right? And then we go to the next level of, okay, great, where am I looking at this part? Am I looking at this immediately next to my injection molding facility, or am I doing QA from my supplier? All of these are different problems. All of these are different data sets. All of these are different camera systems that we can solve with synthetic data. Drilling in a little further, it truly is just that easy, is uploading a CAD file and then answering some basic questions around where exactly are you deploying this system, downloading your Onyx file or your favorite flavor of what your computer vision model is, and then going. And so what we have now is something that happens very often, which is, hey, it's a Friday, and your boss says, hey, guess what? Our customer says that we have a new defect that we need to worry about. Can you work the weekend? Well, congratulations, you're now sitting next to your production line. With Bucket Robotics, what you can now do is take what that ambiguous requirement is, take your CAD file, and marry that together. So right now we're looking at defects for a spur gear where the customer has a defect specifically on surface pitting. This UI that we're looking at is something that we're demonstrating in our booth in the startup environment. And what you're looking at now is generating our defect set so you can actually dial in, hey, maybe I care about only one pit is acceptable, but if I need to iterate rapidly, that's a real question. With Bucket Robotics, you now have confidence to understand what your defects are. We're deployed and running. Our first customer is an injection molding shop across the river, we have deployed this with the Air Force, and we're incredibly excited to show off our defect generation system that we're calling WrenchML. We're giving demos over at our booth in 4609, and we're excited to sign up people who are interested in generating their own data sets, using their own cameras, and moving faster. So thank you all for your time. It's been great speaking with you.
Yeah, just a question around, obviously you create the synthetic data off the CAD part, you kind of get a perfect scenario of parts. Can you dial in what's considered a defect by looking at those synthetically generated images, or like how do you actually kind of set those thresholds?
Yeah, so it actually is, the easiest way to think about it is a sliding bar, and the harder part of that is defining what is an acceptable defect. That's the real power of synthetic data, right? It's very easy to train a detector to say that everything is bad all of the time, but actually being able to tune a knob and say, no, what we care about is scratches on this element and bumps here, really dialing it in regionality is something that works really well with synthetic data that we can provide. So that's what gets people excited.
Who are your competitors?
Yeah, so we are directly competing with somebody like Advex, or what we really look at are folks like Kinisi and Cognex. So our customers today come to us and say, I've purchased a very expensive hardware system, and I still have somebody sitting next to it drawing bounding boxes around the frowny faces. Can you help? And so that's what we get really excited about. We're software first. We've developed this thinking from our self-driving car background of let's use synthetic data well, and let's use the free market to use really awesome cameras.
What's the TAM for this market?
Yeah, so back to Keyence, they're trading at, I think, $105 billion market cap. Depending on how you define surface inspection or even just the pure cartage, that's about $100 billion of waste globally from defective plastic that's thrown away, or maybe you're lucky and reground. So that's just sticking inside of plastic. If you go around to surface inspection, it's terrifying.
And then what's your business model? Is it like a license per seat or per part?
Yeah, so in the last month, we've received a lot of interest around being able to just download the data set. People are looking to do more with less. And so what we have is a software as a service model. You get 20,000 images per month for $500, all the way through, hey, maybe you're doing medical device and you want to license this to do entirely on-prem. So depends on the application kind of thing. But
I think that's it. Thank you.
great, yeah. Thanks, man.
Okay, thank you, Bucket Robotics. So for our next presentation, please join me in welcoming our next competitor, which is Distro.I.
I hope everyone's having a good show. I am Manthan Pawar from Distro.ai. Distro.ai is a new, upcoming robotic operating OS, wherein we are converting a lot of global business data into robot missions. A little bit about me, I come from supply chain robotics, been in supply chain robotics for the last 10 years, worked at a few robotics companies, then moved into distribution system integration. And there I came across a problem, which was this. It is when selecting the robots, it's as a customer or as a distributor, it is a lot. And there's, of course, amazing solutions out there, a lot of them driven through hardware, a lot of them driven through software. A lot of time when we're looking into manufacturing and warehousing operations, the ground reality is a bit different, right? A lot of kind of robotic solutions are built from robotics engineering, and then it's now let's figure out how it fits into the warehousing space, right, or manufacturing space. So our aim, or what we're kind of creating, and maybe just before that, and we can create another slide on the industrial arms. What I showed you was from AMRs and AGV standpoint, but from AMR standpoint, today, someone needs to manually tell the robot, hey, go from point A to point B, here's your next task, here's your next task. And then from that realm, the manufacturing plants or warehousing space, it really cares a lot about workflows, right? Processes that really unlock the ROIs for the customers. So we saw the robots, of course, extremely valuable assets in manufacturing warehousing. But what really customers care about is this, is how those robots are operationalized, what tasks they do, what type of tasks they do, how fast they can do it, and how optimized manner they can do it, right? So with that, when looking at different hardware form factors for robots, what we came across is there are various kind of changes across various hardware form factors, but when you select a particular hardware form factor, like an autonomous forklift, changes are now getting very, very small, right? You have payload changes, speed changes, where it can put. Even on the humanoid side, of course, is a mobile manipulator, what it can pick, how fast can it pick, how fast can it travel, and the intelligence is really on the kind of local intelligence piece, meaning what that robot can see or what that vision system can see. It identifies that, it knows how to pick it and grasp it. So what we are creating is almost like a general purpose global intelligence platform wherein I think local intelligence is really, really important, but then we're looking at kind of global data at businesses as to what is being manufactured, what is the work in progress status, what is the flow of the material, what type of orders are coming in, what type of orders are going out of the warehouse. So what all of that data to drive various different types of automation systems and understand what their individual tasks are. So Distro is a robot agnostic application layer that converts business data into robot missions. We are unlocking, to begin with, some complex workflows that we think there is enough ROI for a software platform like ours. And so that our vision really is you're going to have kind of various robotic form factors, and now it's about downloading this new app that can now unlock a new workflow with robots. So we're trying to create an app store for robots, which ultimately integrated into a hardware platform can unlock various workflows. So as I said, Distro orchestrates robots, agnostic, and we kind of unlock operational processes like work in progress, like cross-talking, and so on. So yeah, that's a bit about Distro. So yeah, questions?
How are your customers solving this pain point right now?
Yeah, I think what we're going up against is almost status quo in multiple cases. So all of the complex material handling processes in warehouses or manufacturing plants, they are either done fully manually. So you have like forklifts, or you have like a pallet jack. So a lot of material handling happens that way. Or if you have autonomous forklift, there's a lot of missions that are driven manually from point-to-point orchestration. So where we're coming in is to unlock more integrated approach towards robotics. So really competing against status quo.
How many engagements do you have, and what's the typical length of an engagement from setting this type of environment up in your customer?
What was the first question?
The first question is how many customers or engagements do you currently have?
Yeah.
The second one is how long does it take to set up this environment with multiple robots?
Yeah, good question. I know Alex mentioned there are various startups here that are like super early stage. We are one of that. We are only a few months in, and we have now a new pilot getting deployed. So just from that experience of pilot, it's a bit kind of hand-holding with customers. Again, we're selecting very, very important large-scale problems to begin with. So setting up something like this is about a 3-week to 4-week time period for us.
I don't really have a question, but I have some advice. I think that it'd be great if you started your presentation with your last slide, that you are an orchestration platform for robotic devices, and then go into the use cases of your POC right now and break it apart and how big of a market that is and so forth. And I say that publicly because there's a lot of entrepreneurs here who can also benefit from that. And I mean, you did a great job setting up the problem. And in this short presentation, we'd love to hear more about how you're solving that problem.
Right. Yeah, no, absolutely. So from our perspective, for us, it's really the data that we manage, and we convert that into robot missions. So there's a lot of data engineering that comes behind that, and that's how we kind of deploy that.
You mentioned the App Store. Are those going to be apps that are developed by you, or are you going to open it up to developers and have third-party apps? Like, what is your sort of long-term vision on that?
Yeah, that's a really good question. I think we're thinking about a few avenues here. We're actually exploring both ideas around selling this into robotics companies as well as to end users. So from that perspective, I think we might see an angle there of how do we open this up for developers where they can bring their new skills and new apps. Then that can be deployed on a humanoid robot or a mobile manipulator or an autonomous forklift. Thank you. Have a great show.
Hello. Yeah.
Hello. Okay.
Yeah. Hi, we are Kemit.AI. We are here to make automations simplified. So we'll start off with introducing ourselves. I'm Nivedita, the CEO and co-founder of Kemit, a former VP at Autodesk, Reliance, and Ford Robotics. Startup background includes being head of product for a $500 million investment company called iMerge. At Ford Robotics was part of the executive team. At Citrix, I've partnered with Shaunak on some interesting technologies that generated over $500 million in revenue. So I am a product of not far from the city, a city called Flint, where I was one of the first worked with first generation electric vehicle, and have commercialized a couple of innovation generating over $500 million and bringing all of this technology and experience into Kemit.
And hi, I'm Shaunak Misri, co-founder with Nivedita. This is the third time, like she mentioned, we are partnering together. Before this, both Nivedita and I, we were at Ford Robotics, where I led the cloud development and software development. Prior to that, I was at Looker, the first architect at Looker, acquired by Google. And before that, I was at another startup where we use data to solve security. The reason why we are talking about our experience is to kind of let you know why we are the right people to build this product. And my data experience and Nivedita's experience is what we are bringing here to Kemit.
So we quickly want to talk about why failures are happening in our industries. We know that there's 1.5 trillion in inefficiencies, and 700 billion relates to machine failures because of interop. And that's where we are coming and simplifying automation. We're building the intelligence hub, and our beachhead focus is machine optimization. So we are changing the paradigm completely. All the tools that you have in the market are monitoring or observability versus predicting. So let's take you through the demo quickly to show you what we are building. We start off with our dashboard, and like I said, we are predicting failures and inefficiencies. We show you with our discovery, where we discover the issues, and with the discovery, you get to know also what kind of problems are there. We predict that, and based on that, we're giving you a rating. And once you have that rating, we act on it by picking up a use case within our systems. And here you have the Mitsubishi Small Range Robo. And then we start giving you the ability to go and configure these robos once again to meet your efficiency requirements. And it's very simple. You just upload your data files. And once you've done that, you use our AI analysis, where quickly we will analyze and give you the right parameters that you need to solve this problem. So here's our data. You can see all of this in our booth. And in addition to this, we have our partner, Mitsubishi Electric, talking about it.
Another point that Kemit can bring benefit to our customer is not only during the setup. Of course, setup time is also important, but we can also provide the data that is captured during the operation. And Kemit will be able to provide us insights from those data and avoid any defects or failure before it happens.
So here's our value. We're talking about 600% ROI. And our partnership, our go-to-market is entirely through our OEM partnership. We are in conversation with other OEMs. And currently we are raising via SAFE. And you can meet us and see our solution, which is available for purchase. It's a SaaS model. Thank you.
How many customers do you have currently?
So we have a partnership with Mitsubishi, and through them, we are expanding through them to our customer base. We just completed the POC with them.
In terms of working with different OEMs, obviously there's a lot of robot arm makers. How are you prioritizing which ones to work with, which applications? Because obviously robots can do a bunch of different things. Like how are you determining which ones to kind of focus on and in what order?
So a little bit of it is being driven by the OEM relationship we have. So we started off with Mitsubishi. It's arm robots for them across multiple use cases. In addition to that, they have another set of AMRs that they're working with, the Kotkin robots, so that's the next level. However, for us, what we've developed, we have been able to utilize the same AI models for Yaskawa, which is another OEM that we've been working. So once we create a model, we can use it across with a couple of tweaks.
So we have currently two models. One is specific to the 6-axis arm robo. So we are focusing on that and expand through that. The second one we have created is for energy consumption on wheels. So that would be another one.
What's the pricing model for the software?
So right now it's $3,000 per month for up to 5 robos.
And how many of, I guess, potential sites do you think there are? Like, what's your kind of bottom-up calculation?
I don't have that
size?
off my head. Yes, I'm sorry.
Okay.
Yeah. But we're looking at least 10 to 15, depending on the customer size. Oh, you're looking for a TAM in terms of? So when you so we started with the arm robo, but specifically our focus area is what we call semi-autonomous and modern machines. So that's about more than 300 billion just in North America.
So I just want to make sure that I'm understanding. This is like only like an operational dashboard to control all these different robots.
So can you repeat the question? I'm sorry, we can't hear.
I said, so as I understand from the presentation, it's an operational dashboard to control these different types of robots, and you're saying up to 5 for your licensing?
Yes, because on an average, based on what Mitsubishi has, it's 10 to 20 per site per customer. Yeah.
Okay, and then how much is one additional?
Well, it's not one additional. It is in clubs of 5 or 10.
Okay,
yeah.
they go by groups
yes.
of 5. Okay.
And what is your breadth of robots that you cover within your dashboard? Is it just Mitsubishi right now, or are you going into Yaskawa? You're going into ABB? And how long will it take you to have a big library to have a full orchestration alert management system?
So I'll answer the last part of your question first, and then Nivedita answer the first part. So what we have built out is our AI models specifically work for the 6-axis robo, which we have built out. It took us around 3 months to build out those initial models. And now that we have built them, we know that they work across, like we've tried them out with 2 or 3 other vendors other than Mitsubishi, although we only have a partnership with Mitsubishi. And we know the same thing, based on what we have done with the 2 models, it takes us around 3 months to build a model not specific to a robo, but specific to a class or type of robo. And I'll let you answer the other one.
So our goal is to expand across other OEMs, and some of them are repeatable with a couple of tweaks in a couple of weeks. So it's all about the partnership. We started and wanted to prove with one OEM, and now one of the reasons to be at Automate is to sign more partnerships. Thank you.
Thank you.
Hello, my name is Brennan Pierce. I'm here as the CEO and founder of Kinisi. A bit of background about myself. I've been doing robotics now for 20 years, and I'm just obsessed with it. My previous companies, I've grown multiples, most importantly sold multiple companies. My previous company shipped 25,000 robots, which makes me one of the rare entrepreneurs that's actually built a company and been successful in robotics. but can't use a thing. So what I realized from my previous companies, where robotic companies stumble is you build a great prototype, you have 1 or 2 successful pilots, but when you actually want to expand, every single deployment, you have to go in there, you have to write a custom integration, YAML files, or behavior trees. This means it becomes incredibly expensive and incredibly hard to actually scale your robot, because every customer you go to, they want something slightly different. 2 years ago, when ChatGPT came out, you suddenly realized you could actually get large language models as agents that can actually do a lot of this customization by using natural language. You could tell it what you want to do. That is what we're trying to do here at Kinisi. Once we started looking at this, I went to about 200, 300 customers to say, why don't you have automation already? What we came to realize is there's going to be 2 types of factories and, well, warehouses. You're going to have your Amazon, you're going to have your Ocado, who are going to spend 400 million on a completely automated solution. But then you have the 3,000 to 10,000 warehouses. They don't want to do the 50 million capex, or, because they literally just rent out space, and they only have contracts for like a couple of years. That's where they want a flexible system where they can deploy it. If they lose that contract, they can move it to different warehouses in their network, and they just don't want fixed assets bolted to the ground. Oh. That's where we came up with our KR1. It's a mobile manipulator that actually works. We have a video later. It can drive around, it can pick up objects, and it can put it down. Our first user case is very simple. Drive to a pallet, pick up a box, bring it to a pack area. For the next 2 years, our northern star is, can it drive around, pick multiple objects up, put it in a box, tape it shut, put a label on it, put it on a pallet. With that, we think you can ship at least 100,000 robots. It's just cookie cutter through all these customers. We already have a robot out there. We also use AI models to actually train the pick and place by using imitation learning, and we're now using NVIDIA's Isaac Labs to actually do long horizon RL. Yes, well, something. So what is the market? A bit of a tongue-in-cheek, $50 billion, trillion. So basically, with these sorts of models, effectively any worker that does anything with their hands could actually be replaced. We started out actually looking at talking to Wendy's, talking to lots of companies for fast casual dining, to supermarkets, to everything. Anywhere that a label person now actually picks up an object and manipulates it could effectively be our target market. Bit of tongue-in-cheek with the competitors. I did my PhD was actually in legged robots, speciality in low-cost compliant robots. Why have 14 incredibly expensive, incredibly custom motors when two cheap wheels would actually do that? It also gives you stability. And one thing, if you want to ask to the humanoid people, what do you actually happens when you hit the E-stop? Is the robot going to fall over? Finally, this is our robot. Obviously, been training it to just pick and place objects into totes to move around. Oh, running out of time here. We have a much better video of our actual successful deployment. Skip that one, skip that one. We get onto here. We actually have these robots deployed in the fleet. We have multiple companies actually sign LOIs, successfully doing it. At the moment, we charge $4,000 a month per robot. Most of the warehouse we talk to realistically see 20 robots in these warehouses. Our first couple of customers, our biggest one has 600 warehouses around the world, and they're super keen. Oh. How I got here? I've been doing this for 20 years. Bear Robotics, I learned how to take something from a prototype, take it to mass production. Here I'm doing it again. And my last slide, I'm also doing it with my co-founder, Ed. Between us, we built bulk billion-dollar companies, raised hundreds of millions, and we're here to do it again. Thank you.
I just want to say good job giving us an overview of your business model and the TAM.
talk about how many customers and pilot right now?
Yeah, we have 3 signed pilots. We started our first pilot yesterday. I'll actually say it only took us 2 days to actually get it up and running, so it's now working. We start with our second customer in a week and our third one in a couple of weeks.
So obviously you get compared to bipedal, robotics, and there's one just down the hall there. So, and if I wanted a robot to go between this desk and the TV, you got a big wheelbase, it's going to have to go all the way around. So
it would get through there, but yeah.
But I mean, you understand, so the big value proposition for humanoids, bipedal humanoids, is the world's built for humans. You don't have to rip and replace. You don't have to change workflow. You can just have them work on the floor. You're a wheeled, like an AMR with hands and a cute head. So, like, what is, where do you feel like your secret sauce will be in conquering that market against bipedal being able to just go right in?
No, great question. I spent 10 years in academia designing humanoid robots. We will build one in like a couple of years. But I feel, as someone that's built companies, you've got to focus and you've got to, what is the secret sauce? I think for these types, including humanoids, the AI models is actually the hardest part. So why overcomplicate, go to market with a second product, which is legs? So that's why we're going for a very simple solution, basically an AMR with 2 arms. And then once we crack that and actually get our foundational models working on that, then in the future we'd probably go for a humanoid as well to augment it. But when you go around factories and warehouses, they're already designed for tow trucks and these things, and why overcomplicate it?
So right now it's 4K a month, right, for the robot?
Yeah, it works.
How much does the robot speed play into businesses' willingness to purchase when they're comparing it to a human doing the same job at that price point?
Great question. This is where our first customers, we had to really be particular what task we want to solve. As we're a new company, we're not going to compete with a dedicated pick and place that's doing like 600 picks, that's crazy. For our early customers, they liked it for these lines where it's not their most effective, popular. So at the moment, they have a person every couple of hours would work there, couple of hours. That's just the entry point. Over time, we should be on par with a person.
And then can it be tasked to do multiple jobs? Like, can it move between stations to do
that is the selling proposition. Over time, as we train the robot with more tasks, it should be unloading trucks in the morning, picking in the afternoon, and stock checking in the evening.
One of your slides said you have a lower cost solution versus your competition.
Yes.
Can you talk a little bit about that as to...
So what I learned from actually shipping robots is you want to keep everything to the minimum. That's where my co-founder at the back waving from Bear Robotics, we partnered with them, so we're buying an AMR that's already done. We've gone to Asia and buying off-the-shelf motors. The only thing we're actually doing the hardware front, because it's basically a commodity, is actually making the parts with 3D printed metal, and then in 1 or 2 years we're out go and get it all die cast. So we've been very lean with our capex as a company. We don't want to go and design custom motors from the get-go. We've been very particular about what functionalities we want, hence why we don't have legs.
Thank you.
Thank you.
Hey everyone, thanks for being here this afternoon. Really appreciate you coming. I'm really excited to introduce to you Nexus Intelligence. We're building next generation software tools and languages for industrial automation. My name is Chris. I'm here at Automate this year with my colleague Jonas. We've spent most of our careers at the intersection of industrial automation and software. Myself in automotive and batteries at Tesla, and Jonas in biotech at companies like Zymergen. Our mission at Nexus is to bring the next 100,000 engineers into industrial automation so that manufacturers can traverse the challenges of today's operational and supply chain environments. We're doing this by building the world's best software tools and software languages for industrial automation, beginning with PLCs and distributed control systems. When you think about software tools today, there's no other software tool that's gotten more attention in the last few years than generative AI copilots. And our first tool is bringing a copilot to the world of PLC controls and industrial automation.
If you talk to software engineers today, you'd be hard-pressed to find someone who doesn't use generative AI in some form or fashion in their workflow. And most engineers say that using these tools saves them between 20 and 50% of their hours. But industrial automation engineers have traditionally been locked out of using tools like GitHub Copilot and Cursor for two reasons. The first is that industrial automation operates on domain-specific languages captured under the IEC 61131 standard. These include languages like structured text, which is a derivative of Pascal, and graphical languages like ladder logic and function block diagram, which aren't captured well in open source code and are typically represented graphically. The second problem is that industrial automation platforms use proprietary development environments like Rockwell Studio 5000 and Siemens TIA Portal and don't integrate into tools like Visual Studio Code. So we're tackling both of these problems by building an agentic coding tool that's an extension of Visual Studio Code. We take foundation models and we train them to understand IEC languages like ladder logic, structured text, and we integrate them really deeply into the existing tools that controls engineers everywhere use. So what you see here is a demo of our system in action. We've taught the models how to think about cyclic execution on PLCs, and we've built in tools like ladder visualization so that as you edit your control systems, controls engineers can see a representation of their program in a form factor that they're familiar with. Once they've made changes to their code and written unit tests using the Nexus Copilot, they can then take the programs that they've written and export it directly back to the vendor tools of their choice. And we've built in a lot of the integration into the XML-based and binary-based file formats that companies like Rockwell use in their control system environments. So here you can see that import process. We take code that was written inside of the VS Code environment, and we bring it directly over. If you talk to software engineers, they'll say that the aha moment for using GenAI in their coding workflow was not when they could go and paste code back and forth into ChatGPT. It was when tools like Cursor and GitHub Copilot brought the power of these models into their workflow, and that's what we're trying to do for industrial automation. So that covers the work that we're doing on the tools section. Next, let's talk about languages. I mentioned that some of the challenges of IEC languages is that they're hard to integrate with LLMs and modern tools. So we asked ourselves, what if we could write industrial automation programs in another language entirely? IEC languages like ladder logic were initially created because back in the day, engineers were more familiar with doing relay logic in electrical schematics than writing C code. So ladder logic was a natural fit to meet engineers where they were and bring the power of PLCs to them. Today, if you were to go to any university, engineering students would be far more familiar with how to write Python than to have even seen what a relay looks like in real life. So if we could reimagine what a PLC and an industrial automation system would do, today we would build it in a modern language like Python. And that's what we're doing with the Nexus runtime. We're building a set of compilers and runtimes so that we can take programs written in Python and compile them in a deterministic and real-time way that can run inside of embedded devices and on controllers, whether they're existing controllers or Linux-based soft PLCs. That project is ambitious and it's in the earliest innings, but we've built proof of concepts and are in early conversations with vendor partners who might integrate it into their platforms. So just very quickly on the business model, on the Copilot, we're planning on licensing software as a service to end users and integrators with the main value prop to increase efficiency. On the Python runtime, again, we're in the earliest innings, but we're in early conversations with control system platform vendors to provide this as an alternative to their customers. We're currently a pre-seed company. We've raised money from investors in Silicon Valley, and we're currently looking for partners on both the Copilot and the runtime model. We're demonstrating our Copilot technology at our booth in 4708. So if you're interested in control systems or you write control system programs, please come find us, have a conversation, and thank you very much for coming.
Great job. Let me ask you, how concerned are you from competitors like OpenAI, that can produce code, and other foundational models that can produce code? Because it seems like at least the first half, that's in their wheelhouse.
We would really love for foundation model providers to do a better job working with IC 611 languages. I think that if you try and compete with foundation model providers in the general intelligence of the models, it's a losing proposition. What we want to do is we want to build that really tight integration layer between the foundation models and the existing development environments that controls engineers use today. So that's like Studio 5000 for Rockwell, TIA Portal for Siemens, TwinCat for Beckhoff. And we want to make it really seamless to bring those copilots into the existing tools. The vendors in this space are building platform-specific copilots. We want to be kind of an open, vendor-agnostic environment where you as an integrator or an OEM, regardless of what brand you're using for a certain product, can bring all of your company's knowledge, documents, and kind of have that repository there that you can bring to bear on any project.
How do you see the future of industrial automation programming changing? Like, do you think you'll have the same sort of traversal from, I don't know, I'm thinking like Lovable to Cursor. I'm curious, are you building for something that's going to change more rapidly?
Yeah, I mean, it's a really great question. I think that one of the primary differences in control systems and web apps, for example, is that control systems in many cases control safety critical, time-sensitive projects. So we really see the Copilot as a human-in-the-loop engineering tool that's going to augment the ability for engineers to develop more complex projects. At this point, we're not looking to take the human out of the loop entirely and build control systems. In the long run, I spent the last 4 years of my career as a software engineer at Tesla. And we had software engineers on one side building great robotics products, and we had controls engineers on another side doing things in the factory. And at the end of the day, both sets of engineers were building products that interact in the physical world and run logic. And I think in the future, these two worlds really need to come together. And there should be no reason why writing code for an industrial automation system is any different than writing code for a robotics application. So it's going to take time, but I think that's one of our primary drivers, is how we bridge that gap and how we bring those two sides together. And that's what we're really excited to do.
How do you go to market with something like this? Like, there's a bunch of different ways. Just curious if you're going to go through like large enterprise and then have them roll them out, or you've seen some approaches where you almost go to like a bottom up and you get the developers like using it themselves and almost pushing it upward.
Yeah, it's a great question. So right now, we've started to sell our Copilot into system integrators and OEMs to begin. These are typically smaller organizations. They're anywhere between like 2 and 25 engineers. It's a lot easier to get forward-thinking integrators and OEMs to sign up for something on a smaller scale, work it into their projects. Our goal is to start with some of those smaller deployments and then go into larger manufacturers and OEMs to not only develop new control systems for new production lines, but also maintain and retrofit older production lines that are already running. So, we'd like to get to those bigger deals, but with the smaller ones, we're able to prove value much quicker. I'm sorry?
Is your model creating a feedback loop with everything?
Is our model...
Is your model like creating, with greater usage, you're getting greater accuracy in your model and creating a feedback loop there?
Yeah, so we don't train our model on customer data. In industrial automation, a lot of people are quite secretive about the IP that goes into their control systems. But what we do is we have telemetry on the actions that you take. So let's say we make a code recommendation to you. Whether you accept or reject that recommendation is stuff that goes back into our feedback loop. And we do use that to improve it over time. Thank you. Thank you.
Hello, I'm Katie Bradford. Thank you for coming to our pitch for Rotate 8. We are designing farmer-first robotics for a healthier world. Rotate 8 designs low-cost, modular, repairable solutions for biodiverse farms. Farms are struggling right now. Labor is expensive and scarce. There were over 2 million open farming labor jobs in the US alone last year, and farm revenue is decreasing year over year. Existing tools are overly expensive, overly complex, and overly specific for a lot of especially polyculture farms, so growing multiple things and multiple terrains, etc. Rotate 8 is designing our precision farming rover, which is a general purpose platform for holding farming implements, and our IoT suite, which connects anything that senses or actuates on the farm to create one farm as a robot system. Our customers have described us as a Swiss Army knife for farming. Our solutions are capable, so our precision farming rover can help with things like soil prep, seeding, weeding, cultivation, harvest aid, mowing, and our IoT system is currently automating solutions like irrigation, incubators, gate control, water pumps, temperature and humidity in greenhouses. It's inherently accessible. We're doing ultra low-cost design by manufacturing in-house with low-cost materials, and our cost of goods is quite low. Our solution is modular, so you can change the base of the platform to accommodate different row spacings, go up over taller crops, and this also feeds really nicely into the right to repair. A lot of customers in the farming industry right now are very frustrated with existing technology. It used to be you could buy a tractor and you own that tractor and you could fix that tractor yourself, and it was like Theseus's tractor. You could keep fixing it for 100 years. Nowadays, you have to have a licensed technician take months with your tractor and then pay thousands of dollars for the privilege when you used to be able to do it in-house. So where our modularity and our open source mechanical designs allows us to accommodate right to repair. It is inherently sustainable, so we're using solar power instead of diesel power. Our lighter platform, compared to a traditional tractor, reduces soil compaction, which protects the soil microbiome, and we can enable precise application of pesticides, fertilizer, and water to also help the environment. And we have a centralized dashboard where you can view all of your devices and automations. We're currently testing on a 127-acre farm in California. This is a very biodiverse farm. We have root vegetables, herbs, berries, orchards, animals, steep hills, gravel, muddy fields. So we're really putting our robot through the ringer right now and testing all these different applications. We have 2 beta customers that we're also assessing their kind of base use cases and easiest applications there. Getting some great feedback on that. One customer told us if we could only do cultivation, they would pay $30,000 for our robot. And we said, great, it's $10,000, buy 3. And we have a number of customers also in our pipeline. The market here is huge, so farming automation is expected to grow to a $9 billion total market by 2030, and our kind of initial beachhead market of local polyculture growers is around $800 million. Just to give you some context, the average farm spends about $36,000 per farm laborer a year, and again, our robot is $10,000, so the ROI is a matter of months, which is really incredible for automation technology. We see our competition not as other robotics companies, but actually as the status quo of unaided manual labor. A recent study showed that only 18% of farms are even interested in automating in the next 2 years, not currently automating, not exploring automation projects, but even thinking about it, which means 82% of farms don't want to automate right now. That is really what we're fighting against in terms of the status quo. So we're assuaging fears in our customers. They're worried about things being too expensive, too complicated, too specific, not right for them. So what we're saying is, okay, our core technology in our robot is a golf cart. It's an electric golf cart that you can put tools on the back of. And you can use this manually if you want, and it's already going to be it's already going to ROI. Now, let's say, okay, in the last couple of weeks, you did the same process 10 times. We can help you automate that. We can build up your capabilities and add automation features as we go and make it more and more valuable as time goes on and as we build trust with those users. Our business model is selling direct to customers, so farmers feel like they can buy their technology, they can own it, they can modify it to their needs, and they can repair it themselves. We're also working with a number of other technology providers in this space who are putting their technology on our platform. So we have solutions for weeding, solutions for seeding, solutions for AI inspection of crops, and we can be the base platform for them to use our technology. We're very easy to integrate with, and if anybody here is interested in that, please let me know after this. Our team has an incredible track record of shipping robotics products as well as farming. So we've gotten our hands dirty. We've understood, the problems that our customers are facing on an intimate level, and so we're designing the right tools for them. We have an incredible team of advisors from farming, government, research, etc., who are eager to help us find product market fit and get our products into the hands of customers who really need it. And I'm exactly at time. Thank you.
So I know Daniel, and he's right there in the back, so I got to be careful what I say. But we're investors in Burrow, which is in the farming space. And as I understand it, there's big wheat and corn, fairly automated, really big, really sizable. And then there's orchards and vineyards, not really looked at, and also like berries and so forth like that, a lot more complicated. Where do you fit? Because your example of that farm, it had multiple crops there. What is your customer demographic? The type of farm that you're going after there.
Yeah, so a lot of the customers we're working with right now have a number of crops, and they can't afford a single tool for a single crop. They're growing 20 different crops for things like CSAs, markets, direct to restaurants, direct to customers. So they can't afford to buy a single $100,000 tool just for their strawberries or just for their lettuce. They have to have tools that can do a number of things, which is currently what something like a tractor or walk-behind tractor does for them. So they can take those implements and they can put it on this platform. They can start automating those processes, and so small to mid-size, growing multiple crops. Yeah. As our beachhead market, but again, very applicable to, if you can have multiple of these and running different implements on larger farms as well.
Cool. I was just going to ask, how do you see that part of the market growing over time?
I hope to see it growing a lot. I think it's really important for everybody in the world to have access to healthy local food. I feel really lucky to live close to farms where I can get fresh, healthy food as opposed to these kind of monoculture, unhealthy, lots of pesticides farms. So having access to that healthy local food is something that everyone should have access to.
Do you know the number of small farms out there in the U.S.?
Hundreds of thousands. It's a lot. It's a lot. It's shocking how many farms there are, and that's another reason why I say our real competition is the status quo, because even if Burrow Farm NG sells 1,000 robots, there are so many farms that need this technology, and I think that rising tide will lift all boats. While we convince farmers that this can really help them, and that they're not make them less anxious to use technology.
That was my question, the transition to the technology from those and what they're currently using now. I think that's a big leap. And how do you think you're going to address that? I think you started to mention it yourself, so I think you're obviously thinking about it.
Yeah, absolutely. I think part of that is starting with really simple use cases. I mean, a lot of farmers, whether they're adopting or not, know that it's probably going to help them, but they might think it's too expensive, too complicated, too specific. So starting with these kind of general purpose tools that can help them even if they're not automated, even if there's no AI, there's no robotics, it's just a very simple tool they can use, building their trust in that, and then adding automation as we go, and then spreading that to their communities as well.
Remind me again, what's the price point of the unit?
So we're selling our robot for $10,000, and then our IoT systems really depends on the application.
And that's $10,000 if it's manual or automated, or is there?
Yeah, and then so if you want to add things like sensor packages or something, for a specific application, that's going to be an additional fee, but it's $10,000 for the base platform. Yes. Okay, thank you so much. Thank you.
Hello, everyone. My name is Shamin, and today I will be introducing you to the world's first safe 3D ultrasonic sensors for robots called ADA. I have ADA here in my hand. I'm going to leave it here. ADA stands for Acoustic Detection and Ranging. Today, we live in a world that is more connected to technology than ever before. We are already seeing last-mile delivery robots delivering food and packages, and very soon we will see humanoids in our homes, being our caregivers and domestic helpers. As autonomous robots become increasingly integrated into our everyday lives, their perceptual capabilities will be further challenged to ensure safe and seamless human-robot interaction. The most commonly used solution today for safe human and obstacle detection is the 2D LiDAR. While it is a mature technology, it has its drawbacks. 2D LiDAR sees only in 2D, neglecting overhangs, objects, feet on the ground, and also it struggles to work optimally in bright light conditions, dusty environment, seeing through objects that are transparent or objects that has dark and reflective surfaces. And LiDARs, safety-rated ones, are also very expensive, costing up to $4,000. So what Sonair has done is to eliminate these challenges with ADA. ADA has 180 by 180 degrees field of view. It perceives its environment in 3D, and it does not struggle to work in dusty environment, bright light conditions, detecting transparent objects or objects with dark and reflective surfaces. And the best part, it comes at a fraction of the cost of safety-rated LiDARs. So how is this being done? This is achieved through a 20-year of research on MEMS technology, which is then used to shrink the transducers to a less than 2 mm PMITs, small enough to be spaced half a wavelength apart to apply 3D beamforming in air, and at a high operating frequency of 80 kilohertz. This is then coupled with our proprietary signal processing algorithms, and the result is a small, patented, and powerful technology. So Sonair is addressing a market size of about 6 billion by 2030. Last year, we launched the Early Access Program, where we had more than 20 global companies across industries and robotic segments who tested our evaluation kit. And the result is the customer orders we received today for the commercial product which we launched last week. We are also on track for safety certification, and we aim to complete this by end of 2025. We are safety certifying ADA to performance level D according to ISO standard 13849 Seal 2. And next year, we'll be focusing on the volume deployments and product extensions. Our ambition is to fuse ADA with camera to complete robotics perception in one product. So Sonair was founded in 2022. It's a Norwegian company. It's led by a strong management team with track records in scaling companies. The overall team has expertise across key domains such as ultrasound, MEMS, robotics, AI, and machine learning. Yeah, so please, everyone, welcome Sonair ADA. Thank you.
What are the first deployments? What are the first deployments? You say you have some early deployments?
Deployments?
Yeah, what are they? Are they AMRs? Are they?
So we have a few customers in Japan and in Switzerland who will be designing in the ADA, which we will start shipping out from July.
Maybe you said it, but what were the first applications? And are you going to focus on certain use cases? Because obviously,
so we focus very much on autonomous moving robots.
And in most of those cases, are they new robots, or are they switching from LiDAR to your technology?
Yeah, a few different situations. There are some that are switching LiDARs, but there are also some that are taking out the extra, let's say, proximity sensors or cameras that complicates the whole sensor package today to mitigate the 2D LiDAR in plain view that they have in order to see 3D. So they want to remove all this complexity for now as first step, and then use it as a safety in further development.
What's the depth of field compared to other?
Oh, so it's up to 5 meter range in a spherical
Only 5, so okay.
Yeah, but
So
that's very
last 10.
sufficient for autonomous moving robots in the warehouse environment.
In the 1980s, programming robots was like programming a computer. Line by line, full of syntax errors. Only a special type of person would do this. Then Gates and Jobs, they introduced the graphical user interface. Suddenly, it changed everything. Anyone could use a computer. But here's what most people don't realize. That never actually happened for industrial robotics. I'm Ken Mackin. I'm founder and CEO of Worker Labs. And we're closing that 40-year gap by building the intelligent interface for industrial robotics. So, robotics, it's in the DOS era. Code-heavy, fragile, and completely dependent on specialists. System integrators. These are these specialists that are like really good at 80s style programming. We've heard about this. Now, they're in short supply. And there's no way to fill that gap because nobody is pushing them out, as we've heard. People want to be software engineers, not control system engineers. For manufacturers, that means high cost to automate anything, even the simplest systems. They're inflexible, and they're one-off systems that are being developed and deployed. Also, teams on the factory floor are every day sitting in fear because they don't know how to recover a robot. Now that's why 90% of US manufacturing is not automated. The complexity gap is real, okay? There's no one that has solved it until now. So, Worker Labs is an intelligent interface for robotics, built to close this complexity gap. Now, think of Worker Labs like Webflow for automation. Powerful under the surface, but really intuitive. Intuitive on the surface. Integrators get modern tools. They get reusable templates, and for faster deployments. Operators can train robots in minutes. There's no code, there's no worries, it's fine. And also, remote support is built in. So when you need help, you can get it. Now here's the shift bot. Worker unlocks the millions of software developers who can now contribute to automation development, multiplying the system integrator workforce 1,000-fold. It's industrial-grade automation, finally usable. We're at a tipping point. It's obvious. Everybody knows, okay? Manufacturers can't hire, they can't train, and they can't scale. The labor shortage is real, and it's permanent. It's not disappearing. AI is redefining software, and manufacturing should not be out of this. Physical AI breakthroughs are finally making flexible automation possible. The market is massive. Industrial robotics software is on the trajectory to hit $180 billion by 2034. Right now, we're sitting at just under 30% year-on-year growth towards that. Our wedge, high-mix manufacturing. Now, this is that 90% of US manufacturers that are frozen, unautomated, but ready to automate today. Now, that's a $65 billion market built for Worker. Worker is a full-stack platform built for the factory floor, not the lab. Our software bus connects over 300 plus robot models, and we're counting. We integrate across thousands of industrial sensors, all the communication protocols, and a plethora of factory hardware you see, legacy and new. Integrators get advanced tools to plan, build, and deploy. APIs, integrations, and simulation with NVIDIA Omniverse. And best of all, operators get a clean, intuitive UI that they can actually use and navigate. It's one platform, industrial grade, and fully upgradable. Worker runs a pretty simple, high-margin SaaS model designed for scale. Okay? We charge a $25K setup fee for our hardware, and then 5-year per robot per license. That's our core license. But the real engine is land and expand. Our pilots convert to multi-seat licenses, and we layer on high-margin modules over time as we deploy and develop them. It's predictable, sticky revenue with long-term expansion built straight into the product. Our GTM engine is built for scale, not headcount. We don't build a massive direct sales force to deploy. We leverage the force multipliers that already exist. We're partnered with OEMs and integrators who already serve that market, this integration market. They have those relationships. We land with a focused pilot, prove ROI, and then expand from cell to line to plant. This isn't labware, okay? This is out in the field working today. We're booking revenue on this, okay? In the field, we're seeing over 95% reduction in how to deploy a robot system, the programming, the setup. We're also seeing over 2 times increase in product utilization, in system utilization. And operator training is now cut down to less than 2 minutes. Honestly, there is no training. We can hand the tablet over to the customer, and they know how to use it. Most players fall into one of these 2 camps. Okay, we have the legacy, the locked-in hardware giants, powerful but very rigid. Or you're a lightweight tool. You're flexible but too weak for any real-world complexities of the factory floor. Worker sits in the top right. We're we're hardware agnostic, software-defined hardware. Okay, we're built for real-world complexity without the complexity. My team combines decades of AI, manufacturing, and software support. We've lived this pain on the factory floor, and we understand those real-world challenges that everybody is facing. Myself, I've been in manufacturing for over 20 years. I've been a system integrator. I'm actually originally a machinist by trade, and I've had 3 successful startups since then. My team and co-founder, they bring a wealth of experience in building software-defined hardware and robotics development for some of the world's largest tech companies. Now, we're kicking off our fundraise at the moment. We're doing a $4 million seed round, and that's to fuel the next 18 months. It will go towards finalizing our V1 product with our customer feedback we're getting. It scales out our core team, and it deepens our channel execution and customer development. Okay, our milestone, we're going for $3 million ARR. And we're going to do that in the next 18 months. It's ambitious, but we believe we need to do this in this industry. We're setting ourselves up to do that, to move on to a pretty much set up for a Series A that will actually direct us into the real industry like everyone else here. Thank you.
So you brought up revenue. So I'm going to ask, how much revenue do you have right now?
So currently we're in pilots. We're booked revenue on those. Because we're looking at LOIs that execute as we deliver, because we work on ROI, that's how we do it. So those numbers are in progress.
So 3 years ago, I interviewed Elliot Horowitz, who founded MongoDB right here, and he founded a company called VM.
Yep.
Just doing the same value proposition here, and it has failed to really unseat Ross as far as market share. So I'm just trying to understand, and there's others out there. You know, your graph was a summary. There's other companies going out there.
Yeah.
Why are you going to win if? And he's raised more money, and MongoDB was a pretty big company. Why are you going to win over others that are going after the same market?
It's really, we hear this all the time. Well, one good thing is competition shows there's a market. It's also been educating that market that's been out there. Execution is difficult. It doesn't have to have all the features. You need to be able to get it to the right people and actually deploy it and see that they have to see that core value. That's what we're focusing on. There's been many players. It's hard. We don't know what the future is going to look like, but we're going to try our best to make sure everybody can use this.
I guess, well said. I guess my question was trying to understand from a product standpoint, why is your product better than VM or better than Ross, better than others out there that are trying to bring down the cost of entry to software developers here?
So I think what we look at is we're not trying to be the replacement to get rid of ABB, Fanuc, Cognex, or any of these companies. We're just trying to bring this together so it's easier to use, deployable, and integrators can actually churn through and actually sell more systems. We've only got 5 million industrial robots on this planet right now, okay? That's what we have. They're doing $35,000 a year labor jobs. That's $175 billion a year right now in labor being done by robotics. We don't have enough integrators. We need to give them better tools. It's not going to be one person that succeeds in this. It's going to be everyone. All these people here are actually moving the needle here. That's what we need to see. Great, there's other companies in this space. These people out here and the customers that are coming in, they want something to happen and they're willing. And that's why they're coming to us. Similar, small teams are coming to us. How do we sort of speed up our deployments? How do we actually service our customers better? That's what we're trying to do.
Can you elaborate more about who your customers are and what they find their main value prop that they like about the technology?
Yeah, so we sell generally directly to the system integrators. So those market is very similar to what we heard. They're a team of 2 to 25. They're trying to compete. They're trying to move the needle and expand their business. They're not the mum and pop style system integrators that have done the same thing the whole time. They see the future. They're asking questions like, how do I integrate a humanoid? Like, that is going to happen. It's that type of mindset. So there's smaller teams. We work with distributors. We have a great network of people that we work with. And they say, how do I, as a distributor, sell this system? So that's what we're working with. We're a small team, but we're definitely moving the needle.
Thank you.
Cool.
Ladies and gentlemen, that brings us to the end of our competition. Please, one round of applause for all of our contestants. I think they did a great job. We are moments away from crowning our champion, but I would like at this time to ask our 5 judges to rise and follow Mackenzie Johnson, my colleague right there. Mackenzie with her hand up. They're just going across the aisleway here for a few moments while they deliberate and decide who has won our competition. You can leave your things. We'll watch your things for you. No worries. And while they're exiting rear of the stage, I would like to say thank you to everyone here. I know that's a lot to take in. That's like watching 4 straight episodes of Shark Tank without hitting the pause button to go get a snack or a bathroom. I appreciate that. That's awesome. You've been an awesome audience. Let's put our hands together for all of you being here. Fantastic. And so relax, take a few minutes. Last year, this didn't take more than 5 minutes. So hang tight. We will be up here to present our winners shortly. Thank you.
All right, everybody, welcome back to the final announcement of today's winner. I want to start by saying you all did an excellent job. It is an honor to be a judge and to be playing a small moment in this experience, and I'm happy to talk with you all after this, excited to kind of meet you personally. But without any further ado, I will let her announce our winner.
And the winner is, drum roll please, Kinisi.